Welcome back to some notes. So now that we know how to graph linear inequalities on a number line, which is what we just had a test over, we're going to look at graphing linear inequalities on a coordinate plane. And that's just a graph. So we're going to look at the difference between graphing a regular linear equality versus an inequality. So the first thing we're going to do is we're going to test a couple solutions. So given the inequality, 4x plus 5y is less than or equal to 12. We're going to see if these ordered pairs fit into our solution. So remember, all we need to do here is substitute, this is x, this is y, into our equation. So I'm going to rewrite it. 4 times negative 3, which is x, plus 5 times 5, which is y, is less than or equal to 12. And as I solve this, I get negative 12 plus 25 is less than or equal to 12. And I get 13 is less than or equal to 12. So I asked myself, is 13 less than or equal to 12? And my answer would be no. So this does not work. It is not a solution to our inequality 4x plus 5y is less than or equal to 12. So let's look at the next one, 0 and 2. So we have 4 times 0 plus 5 times 2, x and y, sorry, is less than or equal to 12. 4 times 0 is 0, plus 5 times 2 is 10, is less than or equal to 12. 0 plus 10 is 10, is less than or equal to 12. Is 10 less than or equal to 12? Yes, it is. So this is a solution to our inequality 4x plus 5y is less than or equal to 12. Okay, let's do one more. 6 and negative 8. So we have x and y, and we have 4 times 6 plus 5 times negative 8 is less than or equal to 12. 4 times 6 is 24. Minus 5 times negative 8 is negative 40, is less than or equal to 12. And then 24 minus 40 gives us negative 26. No. Negative 16, I'm sorry, is less than or equal to 12. Is negative 16 less than or equal to 12? And yes, it is. So 6 and negative 8 are solutions to our inequality. Okay, so now let's look at graphing inequalities. So it says read the directions carefully and look at my work before you do any alone. So for example, graph the linear equality y is less than 2x minus 5 using the following steps. All right, so let's do this together. Simply graph the line as if it was y equals 2x minus 5. Now, we all know how to do that. So we all know how to plot the y-intercept first, which is negative 5. So I'm going to go down to 1, 2, 3, 4, 5, negative 5. And then my slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, now before I draw my line, I am going to look at the inequality sign. So I'm on step 2 now. I've graphed my y-intercept and my slope. I haven't drawn my line yet because now I have to look at the inequality sign. If it is if it is just greater than or less than, your line is going to be dotted. Just like on a number line, when it was just greater than or less than, remember our circle was open. So our line is going to be open, if you want to remember it that way. So if it is just greater than or less than, if your sign is greater than or less than, our line is going to be dotted. If it is greater than or equal to, or less than or equal to, the line we draw is going to be solid, as if it were just a regular y equals, because the sign equal to is in the inequality. Greater than or equal to, less than or equal to. The line is going to be solid. So let's stop there and let's go over here and look at our inequality. And our inequality, if we look back up here, let's make it pink to match our, is just less than. So if it is just less than, our line is going to be dotted. So we're going to draw a dotted line through our points. Okay, so there's our dotted line. Okay, now it says it's time to shade. If the inequality was less than or equal to, and this can be a little bit confusing, but think less than or equal to, we're going to shade below the line. So we're going to go under the line. If the inequality is y is greater than or equal to, we're going to shade everything above the line. So now let's look back at our inequality. It's y is less than 2x minus 5. So less than tells me I'm going to shade below the line. So that means I am going to shade all of this region right here. This is below the line. Okay? So there's a couple steps. You all know how to do all of this. You just have to take it down a couple notches and take your time and follow the rules. Okay? So now what we can do is we can look at any point. Let's look at, well, let's just start with 0, 0. Let's just look at the point 0, 0. And if I plugged 0, 0 into my inequality, so if my point is 0, 0, x and y. If I plug 0, 0, 0 is less than 2 times 0 minus 5. 0 is less than 2 times 0 is 0 minus 5. 0 is less than minus 5. Is that statement true? Is 0 less than negative 5? No, it is not. So this would not be a solution. 0, 0 is not a solution. Now, if I look at a point within my shaded region, so let's look at this point here. So it's 4, 0. That's the point. My x and my y, 4, 0. So now let's plug that into my inequality. Y is less than 2x minus 5. So my y is less than 2 times 4 minus 5. 0 is less than 4 times 2 is 8 minus 5. And 8 minus 5 is 3. So this says 0 is less than 3. And that is true. 0 is, in fact, less than 3. So it does work on that inequality. Okay? So let's try a couple on our own. So let's look at this one. Sketch the following graph. So remember, the first thing I'm going to do is plot my y-intercept, which is 1. Right here it is. Now I'm going to plot, so my m and my b. My b is 1. My m, or my slope, is -3. Or -3/1. Okay, so now I'm going to go down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. I can also go up 3, 1, 2, 3, into the left one. Okay, I have my points on there. I'm not drawing a line yet. I'm looking specifically at my sign. My sign says greater than or equal to. And when it says equal to, I look back up here, and equal to tells me it's going to be a solid line. So my line through my points is going to be a solid line, just like it would if I were graphing just a regular graph, right? So it's a solid line. This says greater than. So greater than, if I look above, tells me that I am going to shade above the line. So above the line in this case is the region, oops, let's use over here. This is considered above the line. All of the values of y are greater than or equal to 1. So it's above the line. And again, we can check ourselves by choosing a point either in the non-shaded or shaded region and plugging it in to see if it works. So let's try 0, 0 again. So if I try 0, 0 and I plug 0, 0 into my inequality, I have y is greater than or equal to -3x plus 1. 0 is greater than or equal to -3 times 0 plus 1. 0 is greater than or equal to -3 times 0 is 0 plus 1. 0 is greater than or equal to 1. That is not true. 0 is not greater than or equal to 1. So it is not in our shaded region. So that tells me right there that I have shaded the correct side of the line, above or below, and I shaded above. Okay, let's do one more, and then we're going to just stop here. So now we have to solve for y first. This is something we've been doing. So we have, let's do this over here. 2y plus 4x is less than 6. I'm going to move the 4x to the other side. This is something we did earlier. Now I have 2y is less than -4x plus 6. Divide everything by 2. Y is less than -2x plus 3. All right, this is the equation I'm working with. So my m and my b, my m is -2 or -2 over 1. And my b is 3, or my y-intercept is 3. Okay, so I'm going to start with my y-intercept. And I'm going to plot my slope, which is -2. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And I'm also going to go up 2 and to the left one. And I'm not going to put my line on yet. I can see right here that my sign in this equation, inequality, is less than. There is no equal to. It is only less than. And when there is no equal to, it's a dotted line. So I'm going to make a dotted line through my points. A dotted line. And it's less than, so I'm going to shade below my line and stopping there.